All right, I just started the last page of CQ27, and first thing it said to do is find the percent by mass of carbon in aluminum carbonate. And so carbon, there are 3 carbons. 3 times 12.01 is 36.03, and I know carbon is 12.01 right here. And then I need to figure out, I have to divide this by the molar mass of aluminum carbonate. 2 times aluminum is 26.98, is 53.96. Now oxygen, there's 3 oxygens times 3, that's 9 oxygen. Oxygen is 16.00, that's 144. I add that to my 36.03, I get 233.99, which is approximately 234.00. So I'm just going to divide that by 234, and when I do the math, I get 36.03 divided by 234. I get 15.397. I times that by 100%. And to even just even 4 sig figs, it's going to be 15.40% carbon. Now it says find the percent composition of oxygen in each of these. Okay, sodium, you know, hopefully by now you know where sodium is. Sodium is group 1 of the periodic table, 22.99. So we'd want to know, first of all, oxygen we know is 16. So 16, we have 22.99 times 2, which is 45.98 plus 16. Let's see what we get. 45.98 plus 16 is 61.98. But again, we have to times this by 100%. So let's see what we get. We have 16 divided by 61.98 is 0.258 times 100%. I get 25.81% to the nearest 4 significant figures. And that's how much oxygen is in sodium oxide. Magnesium nitrate, we know there are going to be, it says 3 oxygens are in nitrate times 2. So I'm going to have 6 oxygens. Oxygen, by now you should know, is 16 grams per mole. Oxygen is 16 times 6 is 96 grams of oxygen. Okay. Magnesium, it's group 2. Magnesium is 24.31. So I have 24.31. I have 2 nitrogens. Nitrogens are 14.01 times 2. I'm doing that in my head is 28.02 plus 96. Let's see what we have. I have 24.31 for magnesium, 28.02, I just put the wrong number there, 02 for the 2 atoms of nitrogen, plus 6 oxygens, which is 96, is 148.33. When I take 96 divided by 148.33, I get, times 100%, 64.72% of oxygen in magnesium nitrate. Now it says to find the percent composition of nitrogen in the following compounds. Well, nitrogen, here there's two nitrogens, which we know is 28.02. Now I know I'm going to take my 28.02, I'm going to add 8 hydrogens. Hydrogens are 1.01 each by now. Hydrogen 1.01 times 8, because 4 times 2 is 8. That would be 8.08. And I have one single oxygen, which we know is 16. When I add those together, I'm actually doing this without a calculator, 16 plus 6 is 22, 52.10. I'm going to take 28.02 divided by 52.1 times 100%, and I get 53.78% of nitrogen in ammonium oxide. Okay. Remember, NH4 is the polyatomic ion ammonium. All right, here we have trinitrogen pentoxide. 3 nitrogens and 5 oxygens. So 3 nitrogens, that's 3 times 14.01. Again, you're doing enough of these that hopefully you don't have to look up at the periodic table every single time. 3 times 14.01 is 42.03. That's how much nitrogen we have. And then I'm going to add 5 oxygens. Hopefully by now you know if oxygen is 16, that's 80. 80 plus 42.03 is 122.03. Times that by 100%, and you get, let's see, 42.03. I actually already had it in my calculator. Divided by 122.03. 0.344 times 100%. I get 34.44% of nitrogen is in trinitrogen pentoxide. Now it says, what is the empirical formula of a compound that contains 25.9% nitrogen and 74.1% oxygen by mass? Remember, I said the first step is to assume I have 100 grams. So we'll change, if I have 100 grams, that means I have 25.9 grams of nitrogen. And I'm going to times it by the reciprocal of its molar mass, which is 14.01 grams per mole of nitrogen. Okay, 25.9 divided by 14.01. I get 1.848. I'm just going to say 1.85 moles of nitrogen. And then I have 74.1%. I'm going to say, again, turn that to grams. Oxygen, by now, you should know, is 16.00 grams per mole. 74.1 divided by 16 is 4.63, approximately, moles of oxygen. Now, which one is smaller? 1.85 is smaller than 4.63. So to find the ratio, I divide them each by 1.85. Of course, this gives me 1 mole of nitrogen. 4.63, which I already have in my calculator, divided by 1.85 is about 2.5 moles of oxygen. Well, do you guys remember what we said to do when we have this? 2.5, we have to multiply by 2. So I'm going to multiply both of these by 2. So we have 2 moles of nitrogen and a ratio of 5 moles of oxygen. So I have dinitrogen pentoxide, N2O5. That was the example they gave us, actually. What is the molecular formula of a compound that has an empirical formula of NO2 and a molar mass of 138? All right, so first step, I have to figure out what is the molar mass of NO2. Well, nitrogen by now we know is 14.01. Oxygen is 16 times 16, but there's 2 of them, so that's 32. So that's 46.01 approximately. I'll just say 46. I now take the actual molar mass and I divide it by the molar mass of just the empirical formula. And I get 138 divided by 46 is 3. So I have 3 empirical formulas for every molecular formula. So for my NO2, remember this is an understood 1, I times them both by 3. 1 times 3 is 3, 2 times 3 is 6. So my empirical formula, or my molecular formula, is N subscript 3O6. All right, we know a certain compound has 64.3% carbon, 7.14% hydrogen, and 28.6% oxygen. The molecular formula has a molar mass of 448 AMUs, which means 448 grams per mole. So the first thing we need to do is find the empirical formula by assuming all of these are grams. So we take 64.3 grams of carbon divided by 12.01. In fact, because there's only 3 significant figures, I'm just going to leave it as 12.0. So I have 64.3 divided by 12. I get 5.35. I'm actually going to say 5.36 moles of carbon. And then I have 7.14% hydrogen. Again, I'm dividing by 1.01 per mole of hydrogen. 7.14 divided by 1.01 gives me 7.07 moles of hydrogen. And then finally, I have 28.6. Again, if I have 100 grams, I have 28.6 grams of oxygen. Divide by 16 grams per mole of oxygen. Hopefully by now you know that it's 16 grams per mole for oxygen. 28.6 divided by 16 is 1.79, I will say, moles of oxygen. Now I'm looking, I have 5.36, 7.07, 1.79. 1.79 is the smallest, so I divide them all by 1.79. Okay, 5.36 divided by 1.79 is 2.994. That's approximately 3 moles of carbon. 7.07 divided by 1.79 is 3.94. That's close to 4, approximately 4 moles of hydrogen, and of course 1 mole of oxygen. So my ratio is 3, 4, and 1. So the empirical formula is C3H4O. All right, we don't put the 1, it's an understood 1. The molecular formula for this compound, we know that the molar mass is 448. I now need to figure out what the molar mass of the empirical formula is. So we have 3 times 12, and I'm just going to use 2 significant figures because it's going to give us a good enough ratio. It's 36, and I'm going to say 4 times 1 is 4, plus 16, so that's 56 grams per mole. So I'm going to say 448 grams per mole for the molecular formula divided by 56 grams per mole for the empirical formula, 448 divided by 56, is 8. So there's 8 empirical formulas in the molecular formula, so I have to multiply each of these by 8. 3 times 8 is 24. 4 times 8 is 32, and 1 times 8 is 8. I had to multiply all of those by 8. All right, last problem. All right, so we're going to do all of these things at the same time. It says a certain compound contains 26.35% carbon, which we're going to change to grams. Again, I divide it by the molar mass, which is 12.01 grams per mole of carbon. 26.35 divided by 12.01, I get 2.19. And I will go ahead and use 194 because I have 4 significant figures. I have 3.30 grams of hydrogen. Divide that by 1.01 grams per mole of hydrogen. Notice the reason I'm doing this is so that grams divide out, right? And then 3.30 divided by 1.01, I get 3.267 moles of hydrogen. And finally, I have 70.35 grams of oxygen. I'm dividing that by 16 grams per mole. And I'm going to put it down here. I'm running out of room. 70.35 divided by 16. I get 4.39. I'll say 4.397. And then I have to stop it because I have an